So in this equation, we're dealing with exponent rules again, and they're asking us to rearrange in a way. So what this means, this express a in terms of b and c, in very basic terms, what they're looking for is something that says a equals blah 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 with b and c somewhere in there. So we need to figure out how to rearrange this so that we get the a by itself and everything else on the other side of the equal sign. So to unpack this problem, one of the things I need to think about is that a is actually tied up in a whole bunch of different stuff. So it's being times by 2, it's being squared, and that whole thing is being taken to the power of 3. So one way I might look to simplify this is actually to get rid of the brackets. So using my power rules, I can take that power of 3 and put it onto the 2, so I get 2 to the power of 3, and take that power of 3 and times it by the 2 on the a squared, so I get a to the 6th. And on the other side, I could leave it in brackets, but to practice this I might go ahead and just times it out. So that power of 2 is going to go onto the b, and remember on that b there's a little invisible 1 right now. So that's 2 times 1 becomes b squared, and c to the power of 4, so this becomes c to the power of 8, 4 times 2. So here I've expanded out by getting rid of my brackets with the power rule. Next thing is 2 to the power of 3 is actually 8. a to the 6 is equal to b to c to the 8. Okay, so I've gotten rid of my brackets, and now the next thing that I notice is that this 8 is being times to the a. So I'm actually going to think about how to get rid of that first. If it's 8 times a to the 6, what would be the opposite of timesing? And that would be dividing. So if I divide both sides of this equation by 8, it'll cancel on the left-hand side, and I'm going to get b squared c to the power of 8 all over 8. And again, I'm just going to write it as a fraction because that's the same as doing a divide. So b squared times c to the 8 divided by 8 can be written out like this. Okay, we're almost there. We've got a almost by itself, but this is a to the power of 6. Remember, that's really 6 a's over here. And we need to think about trying to get it totally by itself. So kind of like x squared, if I took the square root, those will cancel each other out, because squares and square roots are kind of opposites of each other, so I would get the x back. I can take the 6th root of a to the power of 6. So in this case, if I take the 6th root of both sides of this equation, I'll get just the a on one side, and I'm going to take the 6th root, b squared c to the power of 8 all over 8, and I'm going to put a little 6 in here to say that that's the 6th root. So that looks pretty good. I've got a by itself, the 6th root of b squared c to the power of 8 divided by 8, but I've missed something here. We've talked about it earlier in this question with all the different problems with question number 3, and that is in fact that if I'm dealing with even powers, I'm going to have 2 solutions. So here, if I take the 6th root, I'm actually going to have 2 solutions. One is a positive and one is a negative. So you can write your answer like that. A is equal to plus or minus, that's what that means, plus or minus the 6th root of b squared times c to the 8, all divided by 8. So that's 2 solutions, a positive one and a negative one. You could also, if you wanted to, write it out as root 6 b squared c to the 8 all over 8, or negative 6th root b squared c to the 8 all over 8, with that being the 2 solutions. And to carry that rule over, to help make sense of it over here, in fact, if I'm taking the square root of something, my answer here would be plus or minus x, because I'm taking an even root, so 2 possible solutions for it also. And this is what we've wanted for our answer. Just like we predicted up here, it was a blah 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 with b's and c's in it. Here we've got a equals blah blah blah, all this stuff to one side, and in fact that is in terms of b and c. So the b's and c's on one side, the a by itself, totally alone on the other side.